there, and welcome to another Mission Unstoppable. I think this is a case of the little engine that could. Afon Technology, a small firm in Wales, has had a huge breakthrough in the management of diabetes. They have patented a real-time, non-invasive blood glucose monitor that will benefit millions of diabetes sufferers the world over. In fact, there are over 422 million of them. So, who's behind this amazing invention? Well, welcome Dr. Sabih Chaudhry. Hold up your hand. He is a PhD inventor and CEO of Afon Technology. And next to him is Dr. Isamar Masso. She is the Quality, Regulatory, and Clinical Trials Manager for Afon. And Dr. Chaudhry has been on hand for the development of 3 novel cancer-related treatment systems. He played a lead role in the launch of the UK's first wavelength division multiplexing telecommunications system. We have no idea what that is. And project managed the world's first large glass substrate format holographic printer. Sabih's been involved in he actually received an award for the BioNow Healthcare Project of 2014, and he holds a PhD in microwave and telecommunications from the University of Wales. Well, congratulations on that. Isamar is in charge of designing, implementing, and maintaining the quality management systems for Afon Technology. She also leads the regulatory affairs document submission. She's responsible for the risk coordination. She supervises the product risk manager, health and safety officer, and enterprise risk management team. She also performs the duties of Afon's CTM and all of Afon's clinical trials. And she also received she received her scholarship, but she got her PhD in complexity and research methods applied to game research, from which she graduated in 2019. And I just feel so proud of her for doing that. And maybe we'll tell you why, maybe we won't, I don't know. But anyway, congratulations, you guys. 2 PhDs, you guys are married. So is this technology a love story? I mean, Sam, you have diabetes, type 1. Yes. You got it as an adult? That's a little unusual.
Yes. So if you get it as an adult, it's classed as LADA, so latent autoimmune diabetes in adults. So it manifests slightly different from the one you get as a child, but essentially the same thing. It's an autoimmune condition. And I got it while working already.
So you put 1.5, diabetic 1.5. I wasn't sure what that was.
Yes.
Diabetes 1, there's diabetes 2. Diabetes 2 is often as an adult, but it's, sourced differently. It's more to do with what you eat and not the other around. So you were involved with cancer research and stuff. So did Dr. Sabih here, did you start going into diabetics because of your wife, or was this something different?
No, it really wasn't. It was that I was involved in developing 3 cancer treatment systems, and while we were doing that, we thought perhaps there's other biological constituents in the body that we may be able to detect. So we started off with a very, very simple rudimentary experiment to see if we could detect blood glucose. And we literally stumbled upon this effect that we've now started to, or we've been developing for the last 10 years or so. So it was by sheer chance, really.
Isn't that amazing, though?
Yeah.
I mean, so you've done how many clinical trials now? 2? Are you going your 3rd or 3?
We've done 3
in Germany.
So how many does it take before you can market?
It's a whole process. I mean, that's the reason why Isamar is here on board to help develop this, or from a regulatory perspective. But you do need a very, very large number of volunteers or subjects that you can demonstrate the efficacy of your technology. But as you're developing it, you need to be able to run shorter trials where you can quickly go into the clinic, test something out, and use that data all within the framework of a regulated ethics trial as such.
Right.
So that's why we've had a number of short ones just to demonstrate the proof of concept. And now we're going to run larger ones during this year when we're developing the product further.
So are these like double-blind studies, or does it matter? Or
and they're not blind studies at the moment, but I suspect we probably will be running some form of blind studies down the road.
Okay. I don't know why this thing is going. I have a brand new computer and it seems to like play songs. Do you hear it? Strange.
That might be.
Yeah. So how big is the largest study been?
The largest study that we've done to date was 16 volunteers.
Okay.
16 type 1 subjects. But we're looking at trials coming online down the road. We're looking at maybe 50 to 100 volunteers per study. And we'll be looking at different things, type 1 diabetics, type 2 diabetics, and also healthy volunteers as well.
So you put this little technology into a little watch, almost like a Fitbit or kind of idea, and so it's non-invasive. It doesn't break the skin, and normally you would have to test your fingertip to see where you're at or test the blood. So no more strips, no more any of that stuff. It's just this little device that you can wear. That's amazing. I mean, it's like a real game changer, isn't it?
Absolutely. I mean, think of places where there's no running water, so you cannot wash your hands before finger pricking. Or think of just traveling, or you often are not able to carry needles with you if you travel by air. So that would do away with all of that, needing a doctor's letter to justify you're having needles with you and so on.
So do you wear it now, Sam?
I don't have one that we can wear at the moment.
Okay.
But it is that far down that it is a wearable device now.
Yeah.
If I can just show you, Frankie, sorry.
Yeah.
A little bit of PR. So this is our first engineering unit, okay?
Yeah.
And the idea is that it will sit on your wrist, like so. And we'll be using this to conduct the very, very initial trials that we're going to be running over the next 2 to 3 months. So the feedback that we get from that device will feed into the engineering of the actual smaller device that you've seen the pictures of.
Yeah, so the actual antenna will be about this big. So, not
a diameter of like a quarter. Yeah, like a quarter.
Yeah,
something
pretty
like
much
that.
so. A couple of quarters stacked on top of each other. That will be it.
And they would wear it all the time.
They can wear it. Yeah, and they can also take it off. So the whole idea behind our technology, Frankie, is that when we looked at this, so first of all, we're not a watch manufacturer. We never intended to be a watch manufacturer.
Right, yeah.
So what we were developing was a sensor that would be agnostic to any smartwatch out there. Okay, so that was our thinking behind this. So that meant that this device has to be totally standalone. It has to have its own energy source, power source, battery, and it's got to have a way of actually communicating with other smart devices. So we put a rechargeable battery on it, and we put Bluetooth on it. So now what that means is it can communicate to a companion device, which will be like your mobile phone, and also your smartwatch if you're wearing it. So what we'll be doing is we'll have the sensor plus a band, the strap itself. They'll be able to take a Apple Watch or a Android watch, or any other type of watch as well. So and the intention is that it won't need recharging for 2 weeks. Okay, so we've got sufficient battery life in there.
And is it going to set an alarm off if you go too low, too high? So it'll alarm you. You don't have to actually physically have to look at it all the time and say it.
Yeah, so if you're in the middle of your, if you're asleep and you go too low, then it can wake you up so you can, take action, take a glucose tablet or whatever.
Like I just got my kids, actually I bought my dad one. Now the newer one, this new one now measures oxygen level in your blood. It measures heart rate and all that stuff. Can you combine all that into one? Could you go to them and say, hey, let's just all mix and match here? And
well, that all comes down to the app itself. So what you have with something like the Apple Watch is you've got a number of sensors on that device, and that's pulling out all these different information. We would just be yet another sensor, and then you'll have an app that actually combines all of these various parameters together.
So it means you don't lose your other capabilities of your Apple Watch, right?
Right. Yeah, this isn't an Apple Watch, but it's a smartwatch. Yeah. Basically, it's like a Fitbit type watch, except what I thought was interesting is it measured the actual oxygen content, because nobody ever knows that, right? It was kind of cool. Very interesting. Now, I had a dog who was diabetic. Can you make something for an animal? Because you can't. It's really hard to get their blood. Like the pads are really thick.
Yeah.
I'm curious here.
Interestingly enough, that was one of the sectors that we originally looked at. We thought, should we go down for veterinary applications as a first off?
Yeah.
Certainly, because the sensor is a standalone unit, there is nothing saying that you may not be able to put it onto the skin of an animal.
Yeah,
That'd
we
be
have
amazing.
tests to tell you more about how effective it is.
Yeah. No, that'd be really cool for them. I mean, it's a different application for sure, but I mean, he had to get shot twice a day with insulin. So, but you never knew. It's always a guess. It's always a guess for them. So, Afon just specifically does this unit and diabetes. That's all you focus on. And I think, Sam, you said if you're going to do something different, you would start another company.
Yes, that's probably the case.
Yeah.
Why is that? That's interesting. Like, why wouldn't you keep the same company?
It depends. If it's so what we have a roadmap in terms of what our product's going to look like over the next few years.
Right.
So the vanilla device is actually what you're seeing there at the moment, and there are going to probably be variants on top of that device. So with different features, for example, and so. But if we're looking at a totally different sector, I don't know, maybe an alcohol. I'm just throwing that out.
Yeah.
It would need maybe a different type of technology. So we may do it within the framework of Afon, or we may set up a new code just specifically to look at that.
I think it just makes sense from a regulatory standpoint, because a lot of the time the structure of the team has to be different for different sectors.
Oh, I see.
So we might as well do some, if it is in a different sector.
Yeah. So it's a small company, and it's taken almost 10 years. It's taken over 10 years, I guess, to bring this, and it'll take another year or two to bring it to market.
Yeah.
These things take so long, don't they?
They do.
It's incredible.
I think I mean, I've been involved in the telecoms market and now also in the medtech. And the difference is that for example, in the telecommunications market, you will go in, you'll design your system, and you run some initial tests, and then you'll put it into a carrier's house where they can run some tests and so forth, live testing. With a medical device, you're actually playing with people's lives here. So if there's a failure mode, it can be very, very catastrophic. You can lose someone in that. And there's also the issue of the regulatory side of it, which takes time, because you've got, as Isamar knows, it takes time to write the protocols, get the approvals for the clinical trials, run the trials, and then do the analysis afterwards. So it's a much, much longer drawn out process with medical devices.
So were you shocked that they got the coronavirus vaccine out in 6 months?
No, I was really impressed. And
yeah,
it just shows you, the willingness and how much creativity we have across the globe. It's amazing.
Yeah, and people working together, I think,
Absolutely.
It's pretty amazing, and the way that they did it was pretty unique. So how has that changed your lives, if anything? Has it impacted you guys? Your work?
Well, I have to say I'm very impressed with Sabih's leadership during this time, because we're now working from home. So people take turns to go into the lab if they need to work there, but we're mostly working from home. And he has established ways to do things that we're still a team. We still feel like a family, and we're still supporting each other, not just work-wise, but also from an emotional perspective. So I've been very impressed with that, because he just came up with all these ideas very quickly, to keep us running. And we're still working, and we still have our jobs. So this is fantastic for this time.
That's awesome. Yeah.
And Frank, I didn't pay her to say that. But it also helps having an amazing team together that's really willing. That it's always I try and I've tried to build a team of people that are very like-minded, but also bring expertise in different way. And everyone has a can-do attitude in the organization, you know,
So important.
Absolutely. It's very, very important. And that's seen us through quite nicely, actually.
So who would be on, how many people on your team, and like what kind of roles would they have?
There's around 10 of us. We've got a number of engineers, hardware engineers, software engineers. We've got 2-3 people addressing the regulatory side. Isamar's heading that up. And we've got a couple of people doing office support, office managers, and accounts. So these are the core people that we have. And then we also have 3 exceptional individuals who comprise the board. They are, you know, tremendous champions of industry. We've got John Shillingford, who's run a number of clinical organizations, research organizations. He's based in Germany. We've got Professor David Onions, who's taken a number of medical companies from concept through to exit. You know, and he sits on various advisory panels of WHO. And we've also got John Hurst, who used to be the chief exec of the Met Office in the UK. He's a chief exec of BSI, of National Oceanography Society. And having these people around you are fantastic. You know, and the back office, I've got a wonderful team of engineering and support staff. And then at the front end, you know, at the board level, I've got phenomenal people there that are that just want to see this succeed. You know, there's no empire building or anything like that. There's just amazing amount of passion and you know, involvement within the team to make this happen.
I think more importantly for Frankie, it's the thing that impresses me the most is the level of caring. Every single member of the team, from the board down to the, you know, the lowest admin.
Yeah.
They all care about diabetics. They all
Yes.
care about making people's lives better.
Yeah.
And they all care about, you know, just improving the world that little bit.
Yeah.
So
when you tell diabetics that this is coming, like, what's the reaction? Belief, non-belief, like, get it to me tomorrow, like yesterday?
take my money now. Yes, and especially here, you know, in Wales where we are, people are so passionate. They're like, you know, how can we help? How do I get involved? Are you running trials now? Do you need anyone to do anything?
Wow, that's amazing. That's amazing. So what do you think it'll end up costing? US dollars?
Okay, let me
Or,
give you.
or do you hope? Let me finish that. Or do you hope, Sam? Do you hope to get it covered by like a insurance company?
Yes. So that is part of that is one of the reasons we're so dedicated to getting it, you know, all the regulatory approvals that it requires, because we could sell this as a toy, if you will.
Right.
And
a gadget.
Yeah. It wouldn't fly, because we want people to be able to get this under insurance, and we want to make sure it actually is manufactured to the highest possible standard. So
yeah, I cut you off, Sabih, so I'm sorry. Okay, go ahead. What were you going to say?
I was going to say, this is going to be typically comparable with a high-end wearable device.
Okay.
So we're looking around the £500 mark for this.
So 1,000 Canadian, somewhere in there.
Yeah, absolutely.
Yeah.
But nonetheless, I mean, Frankie, it's still a lot.
Oh my God! Like when you count the needles and the glucose strips and the meter and all of that stuff that you have to refill every month, like this is like nothing.
Yeah.
It's like nothing.
And it lasts you 2 years.
Yeah.
So
the battery, because the battery will the battery will only last 2 years? Or?
There's no replaceable parts in there. So
okay.
It's typically like a mobile phone, it'll be phased out after 2 years.
I see.
Because you tend to have a roll off in the performance of the components at that point.
It's funny that you said that, because last week I had the father of the cell phone on my show, right? The guy who invented it.
Yes.
So that was really interesting. You have these 2 engineers and you're going, oh, look at that. I mean, it's the same thing, right? You're whatever technology trying to improve humanity. And he really felt that the cell phone would be the device that was going to change humanity in the health wise for the better. So that was his intention going into it. So I think that's really amazing that, to be able to utilize any of that technology for the betterment, whether it's, you know, you can call your healthcare device, you know, provider and your doctor and over the phone like this, or it's, you know, mental health or whatever, right?
Absolutely.
Yeah, this is, it's very, very interesting. I love to hear about new technologies and where people are thinking, and I mean, it's, you thought of it a long time ago. Like, you've been working on this since, like, really, like, was it like 2005 or something?
That's right, 2005. Yeah, I remember sitting in a very small lab trying to do this, and yeah.
Wow.
A chunk of that time has taken, you know, just to cobble together the cash.
Yeah.
Yeah, yeah.
So
And how big was it before? Like this big? No.
it literally was. When I originally did the first test, it was a very, very complicated test actually. I had a plastic bag full of saline solution, and I had these two receivers that are more designed to picking up satellite signals, you know, and that was it. That was the Heath Robinson experiment that started all this.
Wow.
And I think Frankie, Isamar put it into perspective last year, I think it was, when we moved over from the research side into the development. And we were driving home one night after the board meeting, when the board had basically given its blessing for us to progress into the development phase. And Isamar said to me, she said, you know, does it feel real now? You know, is it a real pinch me moment? And I thought, you know what? For all those years, I had been dreaming about getting to this point, whereas we could actually make something that could go out there that would help people change their lives. And I'm seeing now, when I walk past my engineers' desks, they've got circuit boards, you know, circuit diagrams on there, and they've got little boards that they're making, and it's now becoming a realization that, you know, this thing is actually going to happen.
Yeah.
You know, and there's lots of challenges still to overcome, but it's becoming more of a reality. And
Like aside from, you know, health, the sector, the, you know, the device, medical device, blah blah blah. What physically what other physical challenges do you have? I mean, I'm thinking this is not a device that's going to depend upon or change depending upon you know, what if you're white, black, green, blue, doesn't matter. Like, that's just like, it's not like the COVID vaccine, you know, where it might change or whatever, people's dynamic and internal dynamics. So, but you know, you do have third world countries that there's diabetics everywhere in the world, right? So how do we get it to them and get it out to them? That's a little bit of a challenge, I would imagine. But what other challenges do you foresee right now? That
I think the well, my immediate challenges right now are trying to raise money to take it through to the next to the development phase, and touch wood, you know, we've got commitment for that. But obviously, that this really is a very hard nut to crack. It really is. People have tried this over the years. 30, 40, 50 companies have gone down the pan because, you know,
really?
the technology didn't work. Graveyards littered, you know, with technologies trying to do this.
This is the holy grail of medical devices.
It really is. And so we have got technical challenges. We've also got challenges of how we roll this out. You know, do we get into some form of licensing deal with a big corporate that has got the sales and marketing channels, that distribution channels already in there? And interestingly enough, we've got a very large conglomerate that's onto us with that in mind. And we are getting traction. We're getting traction with some of the big tech companies as well. So, you know, that's a possibility. The other possibility is we go, you know, go and do it on our own. You know, we manufacture and distribute ourselves. So we still haven't agreed on a way forward as yet. So it's still very much up in the air.
Yeah, so we have plans, but we don't know yet how those are going to be realized, if that makes sense.
Yeah, for sure. It's still a little ways out. Is there anything else that a diabetic would need?
Just anyone that can use a cell phone should be able to use this device out of the box. It should be, you know, plug and play style technology. It will be intuitive. We're working really hard to make sure that the usability is all there, so that future users have input on how this is going to work, so that alarms and displays, they're all very clear and understandable. And yeah, so
Well, your gaming background should come into that.
Yes.
Yeah. So I guess I was just, as you were saying that, I just had this thought though. Now, not everybody. I guess there is a what's the word I'm looking for? A measurement. Some people might be 5, some people might be 7. That's a normal for them. And then you go up 15. Oh my God, you better do something. So how do they input what's their normal or where they need to be? Will that be part of this, or is it just going to be a standard? Everybody, if you get above this, let's have a look.
So there are medical values that are considered normal, but as you say, yeah, that does vary between individuals. So the first time you put this on, as you calibrate it, you tell it, like you do with a lot of glucose monitors. Sure. You would tell it, my normal value is between, say, 4.5 and 7. So if I go above 7, give me an alarm saying I'm going up. Whereas for somebody else, it might be, a little bit different. It might be, from 5.5 till 9. So you would be able to customize that the first time you put it on. But this would mean that I cannot put that on you.
Right.
And check your blood sugar, because it's
customized.
Exactly. But in that respect, it's
how long does it take for it to measure, generally speaking?
Within a second or two, you'll have a measure.
Yeah.
So that what will happen with it, Frankie, is the whole sensor goes to sleep, and every 5 minutes it wakes up and it will do a reading and give you a reading, or just store it. So that in case and then if you want to look at the historical data, it will give you that historical information.
So you have everything that has happened, the past 2 weeks.
Yeah.
And this is the reason, and when you were asking how many people we had in the trials, this is why the trials are rather small as well. It's because for each individual we test them on 2 separate occasions for about 12 hours. Mm-hmm. We have thousands and thousands of data points for just the one person.
Right.
And then to analyze that. So so that's the reason we couldn't cope with, 300 volunteers at this stage.
Right. Yeah, that's amazing. That's incredible. Wow. What a feat. You should be really proud of yourselves. I know you are.
I'm proud of the company, definitely. And I'm extremely impressed with Dr. Chaudhry's resilience. He had this idea, and through everything he went through, he kept believing that we could come
pull it off. Yeah. So, that's all it takes sometimes, is just, knowing you can do it. Yeah. Is there anything else you guys want to say to the world?
We're coming.
They're coming. They're coming to take over. Hey.
Well, actually, with the current pandemic, one of the things that people are not able to do, at least in the UK, is you cannot visit your GP so often.
Yeah.
And diabetics are particularly classed as what's the word I'm looking for? Susceptible to catching. Yeah, vulnerable.
Yeah.
So so you avoid it and you stay at home, but that means you might miss one of your checkups, or you don't get the blood works to see what's been happening over the past 3 months.
Yeah.
So this is where we see these mobile health technologies coming to their own, because a lot of people can now monitor their own health in a way that 10 years ago you
right. So. And they have the readout for the doctor, say, look, this is my last 2 weeks or whatever.
Yeah, you can email it to them.
Yeah, yeah.
You can, using telehealth, use a Zoom call like we're doing.
Yeah, the future is bright.
Yeah.
That's awesome. That's great.